In this video, I will discuss the JEE Advanced PYQ from the topic fluid and loss of motion. First, I'll give some basic idea. Consider this inclined plane where there are two blocks. One and two. Let the inclination of this plane be theta. Now, if theta is low, then these two blocks will be at rest. The surface has got some friction. So the force acting on this blocks will be the weight m1 g, and the second block, let the mass be m2 g. So initially they are in contact. So the net downward force will be m1g sine theta plus m2g sine theta. So as theta is increased, at some stage it will start moving, and once it's moving, there are three possibilities. First one, when theta is low, both are at rest. Second thing, when theta is increased, beyond a certain value start moving. One possibility, they'll both move together. Third possibility is both move individually without contact. That is, they will lose contact. And for this to happen, since they have to get separated, this acceleration of the second block A2 should be greater than A1. Initially they are in contact, so the initial velocity is same. So, and for this has to move away from this one, the acceleration of this block 2 should be greater than the acceleration of block 1. Only then it's possible for them to get separated. Now let's consider a particular case where block 1 is smooth. So the friction force between this block and the inclined plane, let me call it F1, that is 0. And block 2 has got some friction. Of some coefficient of friction mu. So F2 is not equal to 0. So in this particular case, I have to check whether the blocks will move together or they'll get separated. So let me assume they lose contact. I will check whether this is possible or not. Suppose they lose contact, then the force on this one in this downward direction will be m1g sine theta. Since the contact is lost, there is no normal direction between them. So the only force along the plane is the weight component. That will be equal to m1 a1. So from this, get the acceleration of the first block or the upper block as g sine theta. For the second block, since there is no contact, the downward force, it's mg m2g sine theta, and the friction force will be upwards because it's trying to move down, and the second block has got some friction. And since it's moving, the friction force will be maximum, which is mu into the normal reaction. Normal reaction on this block is M2G cos theta. So this is the net force acting on this block 2 down the plane. That should be equal to mass into acceleration of the block 2. So from this I get acceleration 2 as g sin theta minus m2 will get cancelled, mu g cos theta. So this is A1 from here, and this is a positive quantity because theta will vary from 0 to 90 degrees. Greater than 90 does not make sense. Even less than 0 does not make sense. So theta is in the first quadrant, so there's a positive quantity. So g sin theta minus some positive quantity. So A2 is less than A1. Comparing these two, I'll get A2 is less than A1. That means this thing is moving slower. So this thing will come and hit this block and there will be a contact. So losing contact is not possible. If contact is lost, then this acceleration of 1 will be more compared to acceleration of 2. So this will move faster and come and hit this block. Intuitively it is clear because since this block 1 is smooth, it will try to come down fast, and block 2 has got some friction, it will try to go slow. So this thing will come and hit this one, and once it is, the normal reaction here will apply a force on this one and make it accelerate, and the normal reaction of this block 1 will try to slow it down and make it slow it down so that they move together. So with this basic understanding, we can solve this JEE Advanced question. A block of mass M1 1 kg, another mass M2 2 kg are placed together, see figure, on an inclined plane with an angle of inclination theta. Various values of theta are given in list 1. The coefficient of friction between the block M1 and the plane is always 0. The coefficient of static and dynamic friction between the block M2 and the plane are equal to mu equal to 0.3. In list 2, expressions for the friction on block M2 are given. Match the correct expression of the friction in list 2 with angles given in list 1 and choose the correct option. The acceleration due to gravity is denoted by G. Useful information: tan 5.5 is 0.1, tan 11.5 degrees is 0.2, 16.5 degrees is 0.3. List 1, different inclination of the plane, theta. Theta is the inclination of the plane. It's being increased from 5 to 10, 15, 20. And the list 2 is the friction value on this block M2. There is no friction on M1 because it's smooth. So the friction value is M2G sin theta, M1 plus M2G sin theta, mu M2G cos theta, mu into M1 plus M2G cos theta. You can pause and look this question. So you have to match this each option in the list 1 with the corresponding correct value for the friction in the list 2. And option A, B, C, D are corresponding to particular matching. So you have to find the correct match and see which is the one matches with the correct option. You can pause and run this question. So this is a straightforward question. The angle of inclination theta is increased. So obviously, if theta is greater than a particular value, both the blocks will move together because just now I showed when the block M1 is smooth and M2 has got some friction, they both will move together. So losing contact is not possible because A1 is greater than A2. So if they lose contact, the block 1 will go and hit M2 and they will move together. So losing contact is not possible. So the force acting on this block down the plane is the weight component M1 plus M2. Since they are moving together, I can take it together, sin theta, and the friction force is upwards and it's acting only on this M2 block. There will be upward direction because it's trying to move down, mu into N2, which is equal to, okay, mass and acceleration. So this is the net force in the downward direction. So when this net force is down 0, then the block will be at rest. So let's find the corresponding value of theta for which it is at rest. So m1 plus m2, m1 is 1, m2 is 2. So this 1 plus 2 is 3. G sine theta. This net force, if you take a particular case where it is these two are equal, then net force is 0. It's mu. Mu is given as 0.3. Into normal reaction is on this block M2. This normal reaction M2, it will be M2G cos theta. Normal reaction, this N2 is only between this block and this one. Between this block and this thing is N1. But the friction force is only here in this contact. So you have to take the normal reaction N2 only. So the friction force is mu into N2, this one. G will get cancelled. M2 is 2. So this will give me tan theta as M2 is 2.2. And they are given this thing. That means theta is approximately 11.5 degrees. So when theta is 11.5 degrees, the downward weight component, which is m1 plus m2 sine theta, and the upward friction force mu into are equal, and they'll be at rest. Okay, so for theta less than 11.5 degrees, this m2g sine theta so the weight component will be less. So in this case it will not move. So the friction force will be the weight component down. This is the friction force. So the friction force in this case will be the weight component acting downwards, that is m1 plus m2 g sine theta. So these first two items, angle is less than 11.5. So the friction force is the balance with the weight component. So both will match with this option 2. P and Q both will match with option 2. So P with option 2 and also Q will match with option 2. When theta is greater than 11.5 degrees, then the block will start to move downwards. So in this case, the friction force will be maximum value, which is mu to the normal reaction M2. There is no friction between the block 1 and the surface. So only the friction force between the surface and the block 2, incline between the block 2. So this value N2 is M2G cos theta. So for angle greater than 11.5 degrees, the blocks will start moving and the friction force will be the maximum friction force, which is mu into N2. That's mu M2G cos theta. So theta greater than 1.5 in the third case and the fourth case, both will match with, in both the cases, block will start moving. So the friction force will be maximum friction force, kinetic friction, which is mu in the normal reaction, and there is friction only on this interface. So just mu to N2, so mu to M2G cos theta. So option R will match with option 3 in list 2, and option S will match with 3. So P with 2 and Q with 2. So option 1 is gone. P with 2 and Q with 2 and R with 3. So D is the correct option. Correct answer option D. This is what I explained here. Initially, the blocks are in contact. That's given in the question, and this friction between this block 1 and this plane is 0. So only there is friction here. So in this particular case, the contact will not get lost because the acceleration of the block 1 is g sine theta. Because there is no contact, there is no normal action. So the only downward force is the weight component, that should be mass and acceleration. So acceleration will come out to be g sine theta for the first block. For the second block, it will be g sine theta minus the upward friction force. That's mu normal action divided by m2. So just mu g cos theta. And theta is between 0 and 90 degrees. So this is a positive quantity. So A2 is less than A1. So contact will not get lost, because if it gets lost means this A1 is more. So this block will move and come and hit this block and they'll move together. So the force acting on this block is the weight M1 plus M2 will be G, and the normal action is M1 and M2, and the friction force F2 between this block 2 and the inclined plane. F1 is 0. And when the block starts moving, this will be the kinetic friction, which is the maximum value mu into N2. Friction force between M1 and incline is 0. It's given in the question, and M2 and incline will be F2. Total friction force F1 plus F2. For the combination to be at rest, the downward force, which is the weight component, should be less than the friction force, and also the, even if less than maximum friction force, will be at rest. Maximum friction force is the kinetic friction, is mu in the normal reaction, m2g cos theta. So for this to be satisfied, theta should be less than 0.2. m2 is given as 2, m1 is 1, so it's 2 by 3 to 0.3, which is 0.2, and theta 11.5 value is given in the question as 0.2. So that means theta is less than 11.5. So for theta less than 11.5, the combination will be at rest. So the friction force will be the weight component, and it is not the maximum friction force, it will be less than the maximum friction force. So this will make P match with 2 and Q also match with 2. And when the inclination is increased beyond 11.5, the blocks will start moving. So obviously the friction will become the kinetic friction, which is mu with the normal reaction. So mu to m2g cos theta. Only the friction is between the second block and the inclined plane. First block and the inclined plane, the friction force is 0. So R will match with 3 and S will also match with 3. So the correct option is option D.